All right, class. So looking into acid-base balance, I want you to remember that our blood has a very narrow pH range. It varies between 7.35 to 7.45. If the blood pH goes below 7.35, we have metabolic acidosis. If the blood pH goes above 7.45, we can have metabolic alkalosis. And in either case, you can have convulsions, you can go into coma, and you can die. Now we know that carbon dioxide is produced by all cells of the body, and that carbon dioxide then mixes with water, as you see in the equation. So carbon dioxide and water combines to form carbonic acid. The carbonic acid then dissociates to form hydrogen ion and bicarbonate ion. Very clear from the equation. Now this equation is showing us the equilibrium state. So everything is in equilibrium. Now please listen to me carefully. An increase, so this is I consider this as the left side and this as the right side. Okay, so this is left side, right side. Okay, now listen carefully. An increase in concentration of any component on one side will shift the equilibrium to the other side, leading to an increased concentration of all components of that side and vice versa. What do we mean by this? Let's do it. So let's look at the left side. Let's say we have too much carbon dioxide on the left side. Can that happen? Okay, too much carbon dioxide on left side. Then obviously you will have more carbonic acid, right? If you have too much carbon dioxide, you will form more carbonic acid. And then obviously you will form more hydrogen ion. Do you see that? So what do we see here? An increase in concentration on this side shifts the equilibrium to this side. So an increase in carbon dioxide ultimately shifts the equilibrium to the right, and we see an increased concentration of hydrogen ion. Good, makes sense. Now let me erase this, and let's take this one. Okay, now let's say we have decreased concentration of hydrogen ion. When you have decreased concentration of hydrogen ion, then you will have decreased carbonic acid, and then the carbon dioxide concentration will also decrease. Do you see that? So any change, so the change in this side shifts the equilibrium to this side. Do you see that? And that is true for increased numbers as well. So if I erase this, if you have more hydrogen ion, that will shift the equilibrium to this side. You will have more carbonic acid and you will form more carbon dioxide. So again, this is very, very important. All right, moving on. So the question is, how does the respiratory system react to keep the blood pH within normal range? Well, if the blood gets too acidic, the first thing that our body does is to exhale carbon dioxide by the respiratory system. Now, the carbon dioxide is exhaled out by the lungs, and obviously that is done in response to changes in acidity, right? More acidic, we try to exhale more carbon dioxide. Now, how is that possible? There are central arterial chemoreceptors. There are chemoreceptors in the central nervous system, which are stimulated by a decrease in pH. So as the pH falls below 7.35, the central arterial chemoreceptors, they sense it, and they then send out a motor command to the muscles of the thoracic cavity, and that leads to a deeper and faster breathing. And as you as you breathe deeper and faster, obviously you are, if you go like this, obviously you are blowing out more carbon dioxide out of your lungs. So in that case, more carbon dioxide is exhaled, less hydrogen ion is made, and therefore the blood acidity reduces and comes back to normal. Know that this is pulmonary regulation, right? Breathing out carbon dioxide when the body gets too acidic. This pulmonary regulation is a fast process and usually effective within minutes to hours, as compared to renal compensation, which we will see in the next chapter. We will see that renal compensation can take days to weeks. So it's a slower process. All right. So moving on to respiratory acidosis and alkalosis, pretty easy stuff. So I'll just read through the slide. Respiratory acidosis is a condition that occurs when the lung cannot get rid of all the carbon dioxide that are produced. So the excess carbon dioxide builds up in the blood and the blood pH decreases, making pH too acidic. If it falls, again, if the range falls below 7.35, you officially have respiratory acidosis. Respiratory acidosis involves a decrease in respiration rate. So you are not breathing fast enough. You are retaining carbon dioxide. And also volume. So you are breathing less volume and at a lower rate. So it affects both rate and volume. Please make sure. So you are hypoventilating. So you are hypoventilating. And the common cause include impaired respiratory drive due to toxins, problem in the central nervous system, which cannot really regulate the respiratory centers of the brain. If you have chronic obstructive pulmonary disease, COPD, or asthma, sleep apnea, airway edema, in all these cases, the condition can lead to respiratory acidosis. Alkalosis, respiratory alkalosis, on the other hand, is a medical condition in which you have increased respiratory rate. So you are breathing faster than normal and deeper than normal. And it elevates the blood pH beyond the normal range. So you are more than 7.45 at this point. And the arterial levels of carbon dioxide is decreased. And this condition is one of the 4 basic categories of disruption of acid-base homeostasis. So obviously the homeostasis is broken at that point. Homeostasis is compromised at that point. Respiratory alkalosis occurs when you breathe too fast or too deep, as I mentioned before, and carbon dioxide levels drop below 7 point. The carbon dioxide level drops below the normal range. And this causes the pH of the blood to go higher, above 7.45. So the blood is too alkaline. When the blood becomes too acidic, respiratory acidosis occurs. So one thing, if you hyperventilate. So what is hyperventilation? Let me talk about that real quick. What is hyperventilation? If your respiratory rate and volume is decreased, we call that hypoventilation. If your respiratory rate and volume increases, we call that hyperventilation. So essentially, when you're hyperventilating, you go like, right? You're breathing deeper and faster. Now, if you continue to do that, if you continue to hyperventilate, what will happen? Are you essentially getting rid of more carbon dioxide at that point? Yes. So you are eliminating a lot of carbon dioxide, and then that might lead to alkalosis, respiratory alkalosis. So remember that if you hyperventilate for long enough, you can lead to respiratory Alkalosis. Okay. All right, so that's the end